On October 29, 2018, Lion Air Flight 610 plunged into the Java Sea, killing all 189 people on board. Less than 5 months later, on March 10, 2019, Ethiopian Airlines Flight 302 crashed shortly after takeoff, claiming 157 lives. Both aircraft were Boeing 737 MAX jets, relatively new to service. These tragic incidents led to an unprecedented global grounding of the entire 737 MAX fleet, an event that sent shockwaves through the aviation industry and raised critical questions about the aircraft's design, its certification, and the intricate balance between innovation and safety. This film will explore the factors behind this catastrophic series of events. Boeing 737, first introduced in 1967, stands as the most successful airliner in history by deliveries. For decades, it has been a workhorse for airlines worldwide. However, by the early 2010s, Boeing faced fierce competition from Airbus, specifically their fuel-efficient A320neo. To counter this, Boeing decided against a completely new design, opting instead to heavily modify the existing 737 airframe. The result was the 737 MAX, promising airlines significant fuel savings and seamless transition for pilots, a key selling point emphasizing commonality with previous 737 generations, according to Boeing's marketing materials at the time. The modifications for the 737 MAX included larger, more fuel-efficient engines, which had to be mounted further forward and higher on the wing. This design change, as documented in Boeing's internal reports, altered the aircraft's aerodynamic characteristics, giving it a slight tendency for the nose to pitch up in certain flight conditions. To mitigate this and maintain the familiar handling qualities of earlier 737 models, Boeing introduced the Maneuvering Characteristics Augmentation System, or MCAS. Initially described by Boeing as a minor system, designed to subtly push the nose down only during high angle of attack maneuvers. Crucially, as investigations later revealed, the MCAS system on the 737 MAX relied on input from a single angle of attack (AOA) sensor. This design choice, according to findings by the U.S. National Transportation Safety Board (NTSB) and other international agencies, created a critical vulnerability. If this sole sensor transmitted erroneous data, MCAS could repeatedly force the aircraft's nose down, making it extremely difficult for pilots to regain control. Furthermore, pilots were largely unaware of the system's existence or its full operational scope, a fact highlighted by numerous pilot testimonies during subsequent inquiries. The certification process for the 737 MAX has come under intense scrutiny. Reports from bodies like the U.S. House Committee on Transportation and Infrastructure indicate that the Federal Aviation Administration, FAA, delegated significant authority to Boeing itself for parts of the safety assessment. Critics argue that this organization designation authorization program, combined with intense competitive pressure to bring the MAX to market quickly, may have compromised the rigor of the oversight. Boeing documents, later revealed in court filings, illustrate the company's internal focus on meeting production deadlines. The Lion Air Flight 610 crash in October 2018 was the first tragic indication of a systemic problem. Investigators, including Indonesia's National Transportation Safety Committee, soon discovered that erroneous angle of attack sensor data had activated the MCAS system, repeatedly pushing the plane's nose down. Despite the pilots' desperate attempts to counteract the system, they were unable to regain control. The flight data recorder, according to the final accident report, showed a struggle between human input and automated commands, leading to the aircraft's fatal plunge into the sea. Just 5 months later, the aviation world watched in horror as Ethiopian Airlines Flight 302 mirrored the Lion Air disaster. The preliminary report from Ethiopian investigators stated remarkable similarities in the flight profile and the activation of MCAS due to faulty AOA data. This second tragedy, with its chilling echoes of the first, made the link undeniable. Countries and airlines worldwide swiftly began grounding the 737 MAX, culminating in a global ban by the US FAA itself on March 13, 2019. The trust in Boeing and aviation safety was severely shaken. Following the grounding, Boeing embarked on a comprehensive effort to address the identified flaws. The primary focus was a significant software update to MCAS. This update, approved by the FAA and other regulators, now requires MCAS to receive input from both angle of attack sensors and will only activate once. Furthermore, it will never command more nose-down input than the pilot can counteract using the control column. Additional changes included revisions to flight crew operating manuals and mandatory simulator training for pilots, a measure many argued should have been in place from the start. The Boeing 737 MAX began its return to service in late 2020, with strict new protocols and enhanced pilot training. While the aircraft has since flown millions of uneventful miles, the crisis profoundly impacted Boeing's reputation and financial standing. It also prompted a wider re-evaluation of aircraft certification processes globally, with regulatory bodies vowing to increase oversight. The events surrounding the 737 MAX stand is a stark reminder of the complex interplay between engineering, regulation, and corporate accountability, and the paramount importance of safety in aviation, a lesson paid for with 346 lives.